Okay, here's what you missed if you were gone for the first part of 3-4. I didn't record the lesson, frankly, because I forgot, but I am going to run through this real quick for you so you can see and hopefully get what you would need out of it and have an idea of where we're going. What I actually have shown here is a graph of y equals sine of x. And so if I would show you the unit circle, we could go through that and get these points plotted. And we're not just using a calculator here. At 0, your x value is 1, but your y value up and down is 0, so we've plotted 0. At pi over 2 is another good one to go to. So at pi over 2, your sine value, your y value is 1, so I've got a 1 there. If I keep going at pi, we end up at 0, -1, 2. So you got to be able to get that graph to start. And what we're looking at is what would the derivative be and what would the second derivative be of sine, so that maybe we can use that later on and maybe that'll save us some time just knowing what it's going to look like in the future. Well, derivative represents slope, so probably the easiest places to look would be if I found where those slopes were 0, where it had a horizontal slope. So just your slope is 0 here. There's another point here where it's 0. So I'm going to plot a point. So I can just go to pi over 2, and I know my derivatives graph should just have a point at 0 there, and a point at 0 at 3 pi over 2 as well. Okay, what else can we do to get this derivative graphed? Well, where is it going to be the biggest maybe? Where is it increasing? Is there a place where it looks like about 1? And actually, I'd say maybe like right here, maybe starting off with a slope of 1. You can see I've kind of highlighted right there in the middle. Kind of looks like it's just going down at that slope of -1, maybe up again at about 1. And I'm not really sure exactly what it is from looking, but I'm guessing I can, well, not guessing, I can tell that that's probably the steepest it's going to get is at that point. So at 0, it's the lowest it's going to get. So it's going to be, and if it is 1, we could do that. So let's just mark it however far it goes down. Maybe at pi it goes, at pi is where it looks like it's the steepest. Maybe it goes all the way down to there. But that's as low as it's going to get. And this is as steep as it's going to get. So that's about as high as we're going to go. And that's the same thing over here. That's as steep as our slope's getting is at that point 0. So that's as high as it's going to go. And if we wanted to, and what part of the exploration in class went through was using our calculators to actually calculate that. So our calculator will give us the numerical derivative and the end derivative if we just plug that in. So if we went and calculated the derivative of sine of pi, we'd get -1. Of 2 pi, we'd get 1. Same, I guess that's the same value then at 1. And if we did maybe pi over 4, we'd start to see that our graph, wow, that's about as sloppy as it can be, looks something like that. If we did the next time, or the next derivative, the second derivative, it would be similar. Well, now I've got a slope here that's 0, so I'm going to have a point there. That's my steepest slope at -1, going down. Maybe up here would be at +1. I'm going to have a slope of 0 there again. Approaching 0 there again. And maybe you notice you end up with something like this. And we spent a little bit of time discussing what's going on. But eventually, actually it wasn't even eventually, it was pretty soon, students were able to come up with this. The derivative actually was the cosine graph, right? What's cosine of 0? 1. Cosine of pi, -1. Cosine of pi over 2, 0. Pretty cool. And maybe you recognize that as well. Well, what about that last one? It took a little while for students to come up with this one. Do you notice that it's actually the opposite of the first graph? See how it's just the symmetrical graph flipped about the x-axis? That's the opposite of sine. And all that was to say, well, we know what the derivative of sine is. It's cosine. What's the derivative of cosine? You get negative sine, and that's not going to change. And we're going to be able to use that. So let me open up. Again, these notes are already finished. I'm just running through a little bit of what you need from them to be able to go on a little further, follow what we're doing when you get back. We'll make some note cards of this, but the main thing, the derivative of sine is cosine, derivative of cosine is negative sine. We also came up with a way to maybe remember that. The derivative of sine stays the same, or the sign doesn't change. Derivative of cosine, the sign changes. So both are just going from sine to cosine, or cosine to sine, but when you take the derivative of cosine, the sign changes, and they were saying sine starts with an S, stays the same. Cosine starts with a C, changes. Maybe a little cheesy, maybe not, but that's the idea. And then all we didn't do anything new here. The derivative of x squared, we've got 2x. The derivative of sine is cosine, but you've got that negative, so it's still going to be negative. That's it. Nothing fancy. B, actually, I ended up having to tell students this. They didn't realize that the x and the sine of x was a product. I mean, they did, but they just didn't think about it that way. So ultimately, we had to use the product rule, which I know that you know that. So you've got vu prime plus uv prime. V is going to be sine of x. The derivative of x is 1. U is x. The derivative of sine is, well, we just learned that's cosine. And I just simplified that. Gets a little bit trickier when you start getting some different, expressions that are a little more complex, maybe having to use some trig identities. One trig identity, the cosine of x squared minus the sine of x squared, actually is the same as cosine of 2x. And I don't expect you to remember that right now. Maybe it'll be one that sticks, not really a common one, so maybe you'll get lucky and you won't even really have to use it again, or it won't come up for a long while again. One that should stick out to you, though, or you will need to use, it does come up a lot, like on what happens in D when we plugged in, well, just the V and the U prime because we had a quotient, was the sine squared of x and the cosine squared of x. So what happened was, when I took V, I took the derivative of that, of the top cosine, which is negative sine of x. Did the same thing, and I get this, and I start multiplying that. I realize that I end up with a sine squared and a cosine squared, which the sum of those two is one you used a lot, should just equal 1. And then probably you notice that at this time, and if I was going a little slower, you'd probably have time to process this and think through it. But if not, I'll point it out. And what I did in class was I rewrote it just to make sure everyone followed. You have that negative sine of x plus 1. Well, that'd be the same as 1 minus sine of x. So by rewriting that, I can see, wait, I have that factor on top once. I have the factor on the bottom twice. Well, I can cancel one of them. So I'll cancel one of the factors and just be left with 1 on the bottom. Just trying to simplify it, almost like some of the trig identities that you used to do. Just trying to use all those and learn all the different ways that you can simplify your expression, rewrite your expression. So we're actually going to use a lot of that. A lot of that's going to come into play. All right, almost there. We're not going to go much further than that. You just have this small little chart here. I'll let you get that down. They give us the function we need. So when they ask about the velocity and the acceleration, we really only have to find the derivative and the second derivative to get those values. And what's happening is, I wish I could do something better visual for you, or give you a better visual for this, but hopefully the audio will be enough. The spring is stretched all the way out. Well, what happens when you let go of it? Well, it's going to start getting faster and faster. It's not going as soon as you let go. It's not going the fastest. The spring is pulling it towards it more and more and more, and it's speeding up. And it's going to be the fastest right around the middle. So if you look here, this is what's happening. You've got, okay, here it is chilling at 5. It's speeding up, so you can see the slope. That's speed. It's getting quicker and quicker and quicker. It gets to the fastest point. Where is it at now? Well, it's at that rest position. It's not expanded. It's not tight. Well, then it swings past that other way. But now it's maybe stretched out the opposite direction. Well, it can only stretch so far. It can't just keep speeding up forever. So now it's slowing down almost to a point where it's like, whoa, I can't stretch anymore. That's as far as I can stretch. And I'm going to start retracting, just coming back towards the center. And you go through the whole thing again. It would get faster and faster back towards the center. And then slow, it'd get to that fastest point, and it gets stretched out where it starts slowing down again. We'll do a lot with that. I'll let you think through some of that. as you see some things applied to that. And then last thing we talked about, well, is my computer frozen here? Just be patient, give it a second, it's thinking. Can I open something else up real quick? Okay. Microsoft Word. Well, let me close it real quick. Just be patient. I know as long as it's still recording, I can just open it up again. And we're really close. What you're going to see last is the derivative of tangent, cotangent, secant, and cosecant. And where you can, I mean, you don't even have to memorize them. Kind of like we're going to memorize sine and cosine. You can actually figure it out. So maybe I'll show you how we figured out one, but then in the end I'm just going to end up telling you I don't even want to recover that. I can't remember the last time I did this. If I close some of this other stuff. Well, shoot, let me just say, and you can look these up in your book then too, the derivative of tangent ends up being, well, maybe, ends up being secant squared. And we'll try to just memorize that, and you could do that by, oh, look at this. It's still going crazy, isn't it? It's like blinking. Alright, let's see if it'll let me open it up. Oh, sweet. Took us a little bit longer, a couple minutes longer for the video, I guess. But I'm going to be able to show what you need. So this is what you're missing right here. The derivative of tangent, well, instead of doing tangent, I have sine of x over x. And all that's going on in all this is I'm doing, or what we did in class was we did the quotient rule. Sine over x, that's a quotient. I mean, tangent is a quotient. Use the quotient rule. And hopefully you'll follow that okay. We simplified it. Well, 1 over cosine squared, what it simplifies to is just secant squared. And if you go to cotangent, we could have done the same thing. Secant, we could have done a proof for all of these. And I would expect that, you know, maybe in the homework you'll be expected to, or if I asked you to, you'd be able to. And I think you'd be okay with that because you're using stuff that we've already learned. But in the end, those starred, circled derivatives, we're going to memorize. And you're going to use them enough where hopefully it'll stick. So maybe at the beginning of class, we'll make some note cards. We'll try to come up with some ways to recall it. But that's how far we got. And that's the shortened version.